Hello everyone, my name is Ćwieka, but like I always say, don't worry about my last name. You can call me Simon and it's completely okay. I work as a DevOps at CyberX and I specialize with big data and CM solutions. And today we will talk about the CM solutions and CyberX CM. I will show you a few screenshots from the CyberX CM. So if you have any questions, please feel free to ask them during the presentation. I'm available on the chat and I will answer them as best as I can. So without further ado, let's go right to the topic. First, we will go through the general overview of a CM. We will talk about a little what CM is, what it can do, what is the purpose of the CM, and then we will go deeper to technologies. So CM is abbreviation from Security, Information and Event Management. And the purpose of it is to monitor architecture for security issues by analyzing data sent to that system, to the CM. So it means that if you have some kind of software like firewall and you want to monitor that data from that firewall, then you can send them to the CM solution, and that solution will look at the data and will try to analyze it and look for security issues. There are few CM solutions, like you can see. That's not all of them, of course, but most popular. I'm sure you are familiar with them. But in general CM, there are few issues that I want to address. Of course, with the proposed solutions. First of all, is that the data that can be sent to the system are selected, meaning that the manufacturer of the CM delivers a list with supported sources. So back to the example with your firewall, if that firewall is not on the list of supported sources from that CM manufacturer, then you are unable to send the data to that CM. And even if you send that data to the CM will just simply not understand it, so the process will be pointless. So the list is delivered with the software. It comes from the manufacturer, and only those sources you can insert the data from. Those sources you can insert into the solutions. The second thing is that mainly only security related events are accepted by the CM solutions. So that means that if you have some software that is that you want to monitor for example performance, then you are unable to do so with the standard CM solutions, with most of the CM solutions, because the CMs are specialized in security monitoring, not performance, not calculations, not standard or custom applications. It's only related to security. Another point is that the data retention for storage is relatively short, meaning that the data you are sending to the system will be not available for however you want. There is a maximum retention time, and after that time the data will be completely removed from that CM solutions, and I think that this isn't good. There should be availability. There should be possibility to for such software to configure your own retention time as you like. Then there is that a lot of CM solution uses SQL databases, and it's not like it's not like that I dislike the SQL databases. It's just a matter that SQL databases are not the fastest one, not designated for such use case as CM solutions. I think that there are better options because the data in the CM are really huge, and the variety of the data is also quite wide, so large. As you try to get results from the CM and the aggregation and so on, the amount of the data and the variety of the data will give some trouble to the SQL databases. And so I think that SQL databases are not designed to support systems like CM. And finally, from the main points, that the data sent to the system often are covered with metadata. Metadata are additional information assigned to those events you are sending to the CM. So, for example, if you are sending data with error codes but no description, and if that CM solution will know what the description for those error codes are, it can add those descriptions. It can also assign categories for those events. So for example, this is a virus, malware, this is a malicious activity, and so on, so on. So the whole categorization process, and those are the metadata. And of course, this is good that the CM solutions are enhancing the data, giving more information for someone who is reading them, for the end user of the system. So he will look at the data, he will see the error codes, and he doesn't have to look for other documentation or have to Google information about the error codes. He just has the assigned to that event, and this is good. But the problem is that there are a lot of CM solutions remove the original data, the raw data that you send to the system. So only the metadata are available, only the information that were extracted are available, like the thread, the priority, category, and so on, but not the original data itself. And I think that this shouldn't be the case. So what is missing? Well, the missing point is that I think that the security analytics, which is the CM functionality, is only a part of the whole. It should be a part of the whole process or whole product. There should be able to also cover the log management aspect and the data analytics aspect, the general data analytics. So CM relies on logs and the data that are already sent to the system. So if we are sending data to the system and the system is able to understand the data, so why we are not able to send any data to the system? The mechanism is already there, it's existing. We are able to send the data, but only the security ones, not the whole, not the 100% of the data in our infrastructure. And why is that? Well, the reason is somehow related to the SQL databases, that a lot of CM solutions will not comprehend the amount of data that that we are sending and the variety of the data. So they will not understand it and will not be able to process it through its crucial mechanisms to extract, recognize the threads, the category, and so on, so on. But I think that if we are able to send the data, and there are some systems available on the market, that CM solutions that can receive all the data there is and accept any data and index it. So if we are able to send it, then we have a proof that the assumption that the CM is SOC for only was wrong, that the CM can only serve that the CM cannot only serve the SOC and also be a help for IT operations and other departments like business and so on. So I mentioned the products that can accept any data CM, and there is another the second side of the problem, which is the cost of license. And as the infrastructure is growing, we want to send more data to that system, to that solution. And here is the trick, that as we are sending more data, often it comes with a higher licensing cost. And not only that, we want to set the licensing on that big amount of the data, and it's okay. If we want to increase the data that we are sending, we have to increase the licensing, so we will be able to work with that increased amount. And it's not the way to go, I think, on the long run. So let's look at the typical sources and overview them for the CM solutions. So the typical sources are like, for example, Trend Micro, Cisco ASA, Oracle, Microsoft IIS, Microsoft SQL servers, Microsoft Exchange, the FortiGate, Apache, and so on and so on. So there are a lot of them. It's only a small fraction of the typical sources that you are usually sending to the CM, but it gives you an idea of what kind of sources can be sent to the system. Now let's look at the security use case for them. So, for example, for Trend Micro, we have a virus detection. The Trend Micro is detecting a virus, and we can alert that by searching the string of field category and the virus of the value of the virus, and we set the few conditions, like the minimum number of events has to be more or 10 or more within the time frame of 10 minutes. So in the time frame of 10 minutes, there has to be 10 events suggesting that there is a virus detected from the Trend Micro, and then we are able to send the information, the trigger, and alert. The second use case comes from Cisco ASA, where we have a good example of how we can use the standardization of huge companies like Cisco, Oracle, and so on, and Windows, for example, where there are specific error codes which are well documented, and describes in those documentations there are descriptions what those error codes mean. So the CM solution is all this has to do is just to search for those error codes, and then it can create an event based on those IDs, like in this case the Cisco ID. Here we have the same case for Oracle, where we look at the specific Oracle code, and it indicates in this case that this is the max licenses exceeded, and we are looking for that Oracle code in the time frame of 15 minutes. If we manage to find that, if the system will send that error code to the CM solution, the CM will notify and create an incident based on that. Another one is from FortiGate, where we have a little different approach. We are searching for attack detected alerting rule, and as you can see, we are combining two strings, where one is a string of attack and the second one is the field of action with the value of detected. So this is condition. There must be a field of action and the value of detected along with the attack string. And if those conditions are met, then we can create an alert. Alerting rule will be triggered. Here we have a use case for Exchange, increased amount of incoming emails. This one is a little bit more complicated, but not very complicated. Basically, what is happening here is that we are searching for a string. We are creating the initial condition. We are excluding fields that are the documents that are not interesting for us, and we are gathering only those which we want to work with. And then we categorize those events by sender address. So each sender has its own group of events, is monitored individually, each sender, and then we apply the condition. Condition is that we are looking for sudden spike of the incoming emails, and how we are doing that? We are doing that time frame by time frame. So we have the time frame of 1 day, then we have time frame of 2nd day, and we are comparing those two time frames. If the actual time frame has a sudden spike compared to the previous one, then the alert is triggered, and the spike is calculated based on this condition. So the spike height has to be 3 times higher than the previous time frame. Here we have an example of DNS anomaly. This is again a little more complicated, where we are again creating the baseline for the alerting rule. We are excluding the countries that we are familiar with, that we know, and we only look at those countries that we don't have maybe don't monitor them very well, or we don't exchange as much information. So the traffic, the network traffic with them is or the business with them is relatively on low level. So to monitor them, we are grouping them country by country, and we are looking for again the spike of the incoming of the basically data from that countries. So if all of the sudden we have a big spike, to be exact, 3 times higher, then 3 times higher from the previous time frame. So if that condition is met, then we can see that the country we don't usually exchange so much information with is now very active, and that is basically an anomaly. And the last one from the use cases here is the combinations of triggering alerts. So it's a logical approach, meaning that we are looking at the alerts that were triggered. Like for example, here we are looking at the Cisco ASA multi-VPN authentication failed. And then we are looking at the second alert, Cisco ASA VPN authentication successful. And if the first alert is triggered 3 times and the second alert is triggered at least 1 time, and all of this is happening within the time frame of 15 minutes, then we have triggered another alert. So those number of matches are the conditions for new alert to be triggered, the correlation between those alerts, and we are even able to set the condition even more precisely, like saying which alert has to appear first and which one has to appear second and which one can be third, and so on. And also we are able to monitor that by specific field, so we can look for the correlation by specific field, like for example username maybe, or IP address, or something like that. So that is the CM in general and the typical sources, use cases. Now let's look at the new scope of data and custom sources. So custom sources are basically everything else that are not related to security and not supported by the standard CM solutions, meaning that like NetFlow, custom applications log, performance measurement, SLA and KPI calculations, and others. So all of those are not usually supported by the most of the CM solutions. And like I've mentioned before, we already have the mechanism of gathering the data, and why not? Why wouldn't we should be able to gather all of that data? I've grouped all of those custom sources into three categories. The first one is infrastructure, the second is security enhancement, and the third one is the business data. So let's start with the infrastructure monitoring, and let's look what we can do. So infrastructure monitoring is basically all of the hardware monitoring, like the CPU usage, memory usage, disk usage, the port utilization, traffic load, and so on. So everything related to to infrastructure monitoring. And inserting that data into the system might not be that difficult. Like for example in CyberX it's really simple, but there is then there is an aspect of parsing, enhancing, and normalizing the data. So there are three steps before the data is ready to be searched in the system. So the parsing part is basically extracting informations that are already in the documents, meaning that we can create fields, combine values, and so on. So we have the information in the event that came originally from the source, and we are extracting everything that there is within that in that event. Enhancing part is giving additional information that we can create based on what was in the original document, original event. Like for example descriptions of the error codes, the categorization, and so on. So those are the enhancing. So we are giving new values that are related to those events. And normalizing is looking at the parsing and enhancing part from a small distance and bringing it to the common scheme, meaning that it will be easier for us and for everyone else where when each source is normalized, and then they have the common naming structures, common fields, and so on. So even if I, for example, came from IT department to the business department for some reason, and I want to get familiar with the business data, then I will always know that the field host will be available no matter what source I use. So this is the normalizing, and it's really helpful for correlating the data, which we will talk about later on. So after the normalizing, we have the proper structure, and we can create the visualizations, alerts, dashboards, reports, and so on. The whole process of parsing, enhancing, normalizing data is applied to every new source. any data basically. So we can see here the visualizations of infrastructure monitoring, like for example the disk bytes per second visualization, the current disk queue length in a single value. Then we have the free space on the disk, so if there is a sudden spike of free space or usage of the disk, or the free space increased, then we can see that this is maybe anomaly, that this shouldn't happen. Also we can sort the data, so we can create the top lists, meaning that we can, like here we can see that disk with the top reads on average, and we can visualize that. All of the data we can also put against the timeline, meaning that in here we have the same value checked like here, but here is the single value, the current disk queue length, and here is the disk queue length over time and over disk. So we can correlate that again on the one chart. Here we can see the memory aspect of infrastructure monitoring. So we can look at the, for example, the paging per second, the memory usage in general, and the memory usage in general over the timeline, memory available in megabytes and in bytes, and so on. So there are a lot of examples, and of course every dashboard you see here is you can edit it any way you want. You can add another visualizations, you can change how the visualizations work, you can exclude some sources maybe. This is all available. It's not the fixed system that you are delivered, and it is as we created it. No, it's just a suggestion that this might be interesting for you. And the use case for infrastructure monitoring is, of course, calculations. So like here we have calculations of CPU total usage, where we are taking the value of the CPU usage and comparing it to the threshold. The threshold is 5.0, so it cannot be greater or the alert will be triggered, and the 5.0 is the 50%, and that is checked over a time frame of 5 minutes. So the 5 minutes time frame, we are checking what is the utilization, the usage of the CPU, and if it's greater than 50%, then we are alerting. Very similar is with the high paging detected, where we are grouping everything by the hosts, and we look at the time frame of 5 minutes. If the paging is high, over the 400, then the alert will be triggered, but only per host. So it's not the general monitoring of the paging, it's grouped by host. So each host individually, to trigger the alert, each host individually has to have the value greater than the threshold. And here we have the example of bringing value to the average from the inputs outputs monitoring of the disk, sorry, the CPU IO8. So we are monitoring the CPU IO8, grouping it by host and bringing the value to the average. So from the 5 minutes time frame, we are taking the average value, comparing it to the threshold, and if there is a violation of that threshold, then alert will be triggered. Now let's look at the APM, which is the application performance monitoring. So custom and not security related applications are almost impossible to be monitored by standard CM solutions. And why? Again, because the unique data format of the applications, because not every application has to follow the designed format. If you are writing your applications for your own usage, then you don't have to follow the you don't have to follow some kind of procedures and so on. You have the free will to create anything you want and how you want it, and we believe that you should be able also to monitor it with a proper tool. So APM looks like this. This is some example, like where we can select the source, the type of the applications, and then we can monitor whether the calls are okay or slow. Like in this pie chart, it's 50-50. We can see the average response time with the green background, which indicates that this is the good value, 1 millisecond. The average error codes per minute, which is 185. The yellow indicates that this isn't a good, it's a medium level, and the total exceptions of 477 per minute indicates that the coloring of dark orange indicates that this is the value that is getting really close to the red lamp, to the trigger. And here also we can see the response time of the applications. We can set the maximum values and the minimum values, which we can see because they are behind the response times bars, and we can monitor how it behaves. In here we can see the, for example, error codes per minute with the exceptions per minute, so we can correlate those two values, or we can put on one graph the infrastructure error with the errors per minute. So we can, with the naked eye, just looking at it, we can see if there is some kind of correlations. We can also here see the average response time per applications. We can see the top visited URL or the URL that took the most of the time to process. Same is for the session, so we can, if there is a long time for long processing time for applications, then we can look if it's the URL reason or the session reason. And here we have the table with the information of, for example, results of, in this case, our errors, error codes, and components, the sessions IDs, descriptions, and so on and so on. So there is a free will to create such tables as you like. And the use cases for alerting would be like, for example, this, where we have a high response time with the definition of, again, bringing response time to the average value, grouping it by the application, so each application has its own average value, and over the time frame, of 5 minutes, the average value, and we are comparing it to the max threshold. And in here you can see that there is a possibility to monitor the selected application, the selected few applications, or we can just remove the whole brackets section, put the asterisk, and we can monitor the applications, every applications and response time. High error count is the another approach for this, where we just bring the count of the errors to the average value from time frame of 5 minutes. If the average value is bigger than the max threshold per application, of course, then we have the alert triggered. We can also monitor the single components failing without using the calculation, so we don't have to bring everything to the average. We can monitor it by looking at the component that is indicated that is failing, so it has the field of error number, and we look at the time frame of 1 minute and grouping it by component. If the single component has big amount of large number of failing of errors, then we can trigger the alert. Now let's look at the SLA management and KPI calculations. So KPI calculation basically is very similar to the APM because we look at the values, whether we are calculating it for the applications or for the KPI or SLA or anything other. It's not that big of a difference. The approach is pretty much the same. We are looking at the numbers, the values, calculating it, and then compare it to the expected results, and then we can build the whole monitoring of the KPI and SLA management. So we would have to do, compared to application APM, of course, we have to do a reworking of parser and enhancing data. But other than that, the whole process is really similar. The specific thing for KPIs are that we don't always know exactly what what thresholds they have. So if the KPI have a value of 1 million, so is it good or is it bad? How to present that? And we are using the percentages mode, where we can bring all of the values to percentages, and no matter who will look at the data, will always have the really clear information if the KPI is behaving as expected or is it below the expectations. So here is the example of such visualization where each row is representing the different KPI, and each KPI has 3 different visualizations. So there is a general traffic light visualization, there is a single value visualization, and the values over the time. And below we can see that, for example, we have the general information, general state of the KPI is good, is green, the value is 96%, and we see that in the timeline we had a few downtimes of that KPI, but general it is good. We can see the interesting aspect that the expected value is above 80%, but if we see on the time chart the line, we can see that there was 4 incidents where the KPI dropped below the expected value, so below the 80%. And now what we do with that depends on the KPI calculation method and the agreements, the contracts, and so on. Because if you have a contract that you have the KPI has to be available 100% of the time, then such incidents and such downtimes will be something that you have to address. And if you are calculating the KPI on the monthly basis, for example, or weekly basis, then such a downtimes will not be a trouble for you, because the general, in this case, for example, the general availability is counting. Here is a use case where we present the KPI on the two components. We are presenting 2 components of the single KPI, and we are calculating those components to a single value. So here, for example, we can see that there is a OSM1 and OSM2 components, and we are bringing it to the single value, and we can see that the OSM is expecting 99% KPI availability, and we have the 95%, so it's below the expectations. We can see that the OSM1 is behaving a little lower, worse than expected compared to OSM2. The rest is behaving properly, so we have the flat line, we have the green traffic light, and everything is good. Now let's look at the IOC and MIP, which is the section of security enhancement. So IOC is the abbreviation for indicator of compromise, and MISP is abbreviation for malware information sharing platform. So the MISP is used by many companies across the globe, which are connected to this platform, and they exchange information about the threats and malwares and so on. And integration with such a database is huge advantage for CM solutions to increase the value of security. So it will allow a company to be prepared for new threat that they didn't see before. And how is that happening? Well, imagine that in Poland you have a company that discovers new threat. New threat is attacking that company, and they are connected to the MISP platform, so they are exchanging information about this threat. Now, every other company that is connected to the MISP can download those informations, and when the threat will travel from Poland to anywhere else on the world, the companies that are connected to the MISP will have already the information about that new threat and will be able to defend better against it. Will know how it behaves, what precaution to take to avoid being compromised. The MISP platform looks like this. It doesn't have to be pretty. It isn't really pretty, but we won't look at it. We are integrating with it, so we don't visit it like typical way. But I wanted to show you how it looks like and what information we can gather from that. So we have information like, is the threat published? Because we have the option on the MISP to register a threat but not yet publish it. We can see who is the creator, what is, for example, the attack patterns of the threat, what are the tags associated with it, the additional informations, and so on, so on, so on. And then we are able to integrate it with create the own databases from the MISP integration, where we are downloading the updated databases and then inserting it to the system, so the system will be able to use them and give us additional information about the threat. Is the threat active? Is the threat new? Is it old one? And so on and so on. So here we can see the use case for that, where we have the of course the virus detection, the Trojan, and we have we can see the tags assigned to that events, where the bad URL indicates that the Trojan was detected by visiting bad URL, and MISP blacklist indicates that the threat is confirmed at the MISP database. And the alerting rule use case is really also easy to use. Basically, what we are doing is, in this case, is the DNS resolve domain matches IOC IP blacklist. So we are taking the information from the specific field, which is in this case domain IP, and we are comparing it with the blacklist of from the MISP. If there is a match, then we have the alert triggered. Now let's look at one of the most important aspects of the CM and such powerful tool, which is the correlations. So I believe that in IT ecosystem, nothing happens without a reason. There is always action which produces a whole chain of reactions. There is no case where information appears out of nothing. The simple example is that if you log in to a website, you just type the username and the password and hit the button and you're in. But behind that there is a whole process of information, whole process of connections, and so on. So this web service, for example, has to authenticate you, connect to the database, verify privileges and permissions, so on. So that is a huge chain of events, and every incident, every element of that chain happened because of a simple user logging. And a key of understanding the correlations is you have to have the proper perspective, like the step back, have the all information, and look at it with combining those informations. If we have all the data, we can correlate events and have the wider perspective on our architecture. So this is the simple use case I've prepared to show you how we can monitor the correlations. We have three different sources. One is from the security softwares. There is infrastructure software sources and the business sources. Each perspective is monitoring his own things. So we are looking at the security perspective and we see attack. Okay, the attack was denial of service, so it attacked the web services and the traffic went down. With the traffic going down, the website is being unavailable, the sales can also go down. And without correlation, each perspective, each department will look at his own own part of the data and will react only to that. So meaning that the security will see that there was an attack and they will like, okay, so how we avoid that in the future and so on. But the infrastructure perspective, now they don't know there was an attack because that's the security perspective. All they see that the web traffic is going down, the websites are maybe unavailable and so on, and it depends. Maybe they will identify this quickly, maybe not. Maybe they will look at the services, hardware, memory usage, so on, disk space, and other aspects of infrastructure, how the application is performing, and so on. But the core of the reason because this happened was the attack. And as the traffic went down, the website was unavailable. Here we go to the business perspective, where they will look at the data and they will see all of a sudden that there is a drop in the sales. And they will start thinking, okay, so maybe it's stock market, maybe marketing campaign didn't go very well. What else it could be? So you can see that each department is looking at the data in its own way. When the whole chain of event is so connected that you should be able to see the whole chain of event, the whole correlation of that. With that correlation, you save so much time for each department. So the security will see that there is attack, okay, and it has affected the infrastructure. And even if they won't give a call to infrastructure guys, to infrastructure department that there is attack, watch out, you will have web traffic down. If they won't give that information, the infrastructure department will look at the information here and they will see, okay, so we have the traffic, web traffic going down. This is because there was a attack. This is the clear correlation. Now let's look at the IT data warehouse. So we have a lot of information so far in our system. We've gathered a lot of them. We are able to correlate them. Now, how avoid being overwhelmed by those informations? To avoid that, we have to go one level higher. So we have to look from the bigger perspective, from higher level, from high ground, to at the whole infrastructure, group them, and be able to still see the incidents and potential problems. This is the example of such use case, where we have the whole informations gathered for monitoring warehouse, where we have informations from the warehouse like the average response time per applications, average response time per group of applications, how many of applications are running and stopped, what is the disk usage, the active and queued query, so the how query is efficient, and also the infrastructure aspect, meaning the CPU usage, and so on. So monitoring warehouse is combining the informations. We can also monitor the applications per host, how many applications are running on specific host, how many applications are running in specific group, because in this case each application has its own group, like audit, service, connector, and so on. We can see the average response time per group, and we can see also the heat map. We can see the group statistics, like in here we have the service group. Inner circle is the host, the outer circle is the applications, so we can see how many applications from that group are running on that host. Here we see the filed important connectors. So inner circle is again the hosting, middle circle is the priority of the connector, so each connector has 1, 2, 3, 4, 5 level of priority, and within that group how many applications are failed, with how many connectors are failed on that priority and host. And the use case from alerting standpoint is, like, for example, detecting new applications. So we can look at the hosts and we can see what was the last time when we saw the application. If we didn't see these applications before, then it's new. We can set the time frame for example, 30 days, which is also a security measure. Yeah, if it's a new application, then we can trigger the alarm regarding that. So now let's look at the asset management, where asset management, at this point we have a good picture of what we have, what we can do, and what we want. And the next step is to again combine everything. And there is a huge amount of information, and CM solution should be able to do that. This is the use case for such asset management, where we can see the big numbers of applications, hosts, services, databases, and so on, where we can monitor aspects of those. For example, top Unix memory usage, same for Windows below, CPU usage for Unix and Windows below. We can also monitor the virtualizations and containers aspects, so we can monitor the pods running, the CPU usage of its over time, and CPU usage in average, and so on. Also, we are able to monitor even the NetFlow usage, the network usage. And from the pod we can go to the node, where we per node can see the IO monitoring, CPU usage, load, everything can be placed on the chart with the correlation aspect. Now, aspect of asset management is application management, where in this case we don't know where application will be running. on which host, because the environment is so dynamic that if the application failed on one server, it will be running on another server and so on. So we can't monitor this in a classical way. We have to have dynamic approach and to detect the applications running and understand in which groups they belong to and so on, to have the proper categorizations. Here is the monitoring of Apache slots per port. So how many slots they are per port, for example 80, 443, 8008, and combining it with the time aspect, timeline. So for example, Apache reading, sending, count, how much of the busy slots they are, and so on. And the evolution of that is the natural evolution, we can say, the configuration management database. So we will be able to manage the configuration of whole environment, and then it will be the true heart. The CM will be the true heart of the company. And the best part is that this is really possible to achieve. So the whole story is about the two things, that the CM tool should be able to accept all necessary data, not only related to security, all of them, everything from IT ecosystem. And the other part is that the CM as a true central point should be joining teams, not dividing them. So we should drop the case where every team has its own tool for monitoring and so on. We can now use one tool to monitor and correlate everything, and there are so many advantages of that. Like for example, it's cost effective, budget effective, managing correlation, and so on, information exchange if needed. If not, then this can be restricted. And the last point is that the possible integrations should be able also with other CMs. So forcing customer to transfer from one tool to another is really demanding, I would say, because such transformation is really difficult to achieve. It's risky, time consuming, and so on. What I think that CM should do, and what I know we do at CyberX, is to integrate with other CMs. So if the customer wants to stay with his solution and take advantage of CyberX solution, then we can combine those two and work together, no problem. If the customer wants to slowly transform from one solution to another, then this is completely okay also. So as a leader of the company, the CM, I mean solution, as a leader of company, the heart of the company, it should be able to accept any data also from other very similar tools. So that is all from me for today. If you have any questions, please feel free to ask them. From my side, I just want to ask you to ask yourself if you are monitoring everything in your infrastructure as good as you would like. If you are not monitoring everything, then why you are not monitoring that? And when you have those questions and answer to them, please come visit us at CyberX, and we will see about what is possible to achieve and what is not possible, and are you sure that this is not possible. Thank you, and have a great time.